Welcome everybody to the Tile Roofing Industry Alliance short course on snow retention for tile roofing. Lisa is going to be monitoring. She won't actually be presenting. And I'm John Jensen. I'm the Tile Roofing Industry Alliance training manager. And in addition, I'm a roofing contractor that spent most of my career up in the Pacific Northwest. And our featured guest speaker today is Mindy Dahlquist. She is the business development manager with TRA Sun and Solar. A little bit about the Tile Roofing Industry Alliance before we get started. We are a manufacturers organization, but we also really thrive because we are including and utilizing our contractors and suppliers and inspectors and consultants to really create a professional industry where we become the resource for tile. Our manufacturers develop manuals and code compliance documents, and in addition have technical resources. We also provide service to consumers with a contractor search and also the ability to search for a supplier, inspector, or consultant or other roofing professional. And you can see the map there. So if you went to our search, you'd be able to dial in by your zip code. And the way that you get onto that map is by taking one of our manual certification courses. And we have two manuals. Both are code compliant. They are developed between our manufacturer technical group, which includes contractors and consultants and manufacturer personnel, and the Roofing Contractors Association. In the case of the regular manual, the regular climate manual covering 49 states, that's the Western States Roofing Contractors Association. And then down in Florida, where that manual is Florida specific for high wind, that is a partnership with the Florida Roofing Contractors Association and the Tile Roofing Industry Alliance. Both of those manuals are produced, and we provide a class, online class, and soon, again, after the first of the year, we'll be back in person in the classroom. And at the end of that class, which is focused on the manual itself, you have a test, and if you pass that test, you'll be what we consider to be manual certified, and that's how you're qualified to get onto our contractor search. In addition to those trainings, we also have these short courses. Mindy Dahlquist is, like I said, the business development manager for TRA, Snow and Sun. And while she was working with a commercial snow removal company, she really learned and gained respect for the potential damage and challenges that heavy snow in mountainous regions can cause. So she learned the dangers of the work involved in removing it and how it can accumulate and really cause issues. So now that she's with TRA, she has learned that rooftop snow retention is really the safest way to deal with that heavy snow accumulation in those areas. So I think Mindy will bring not only the recognition of the challenge, but also some solutions for us today. So Mindy, we'll turn it over to you, and thank you for being here today.
No problem. Well, let's go ahead and get started. As John had mentioned, that I am with TRA Snow and Sun. My name is Mindy Dahlquist, and we are going to learn some stuff today. We're going to kind of go all over the board, and I speak pretty quickly, so if there's any issues with that, please just let me know. I just want to hit over a lot of information very quickly. So our learning objectives today are going to be just to discover the danger involved when snow and ice moves on a roof, take a look at how heavy snow can be, recognize just some of the damages that are associated with snow and ice moving on a roof, take a look at DIY solutions, some of them that work, some of them that do not, and present similarities and differences of brackets and fences. That way you guys have some knowledge of these different types of things that can be applied to the roof. Prove the importance of testing and engineering of snow retention systems, and also take a look at some design practices that doesn't have as much to do with snow retention itself, but just very helpful design practices for the snowy and mountainous regions. These first pictures we're going to take a look at are actually screenshots from a video that we normally do show. I still wanted to show these because I think it's very important to see what kind of snow we're talking about. The picture on the left, that snow has already fell, the majority of it from the roof, and still there are these major size pieces of snow and ice coming off of the roof. The one on the right, that snow is all in one giant mass, and as it's coming down, it just is not something that you want to happen on your house or to be happening on your neighbor's house or any type of public buildings as well. So with that, you can see we are talking about heavy snow. This is probably a little bit of a dramatic version, but this is in Lake Tahoe, California. So with that, you can see we're not looking at a skiff of snow or just a light coating. It is not light and fluffy. Once that snow accumulates, it actually glaciates. So what we're seeing here is a picture of where the snow has stayed in one massive piece and has actually removed the dormer off of this home. And I don't know about you guys, but I couldn't imagine working 8-12 hours a day, coming home and having to deal with this. What do you even start with there? So our first learning objective is going to be discovering the dangers that are involved when snow and ice moves on a roof. So with that, we will take a look at some examples of fatalities in the United States that have been caused solely by snow and ice shedding from a rooftop specifically. So I normally I have longer trainings that I do, and with that, I usually show one of 3 separate videos. And those videos all include the March 4th, 2018 death, the 2017 death, and the 2016 death. So those are 3 different scenarios in 3 different areas. And when they were all taped for the newscasting, they all called it a freak accident. So if it's something that happens yearly, we truly don't feel like it's a freak accident, and we think that it's something that can be prevented quite simply. So learning objective number 2, how heavy is the snow once it accumulates, and when does that snow become dangerous? So ground snow loads are going to be how we kind of base this entire conversation. Ground snow loads are basically calculated from the historical data of the worst snowstorm in the past 50 years. Obviously, there's a large amount of other information that goes into it, but this is just how we're going to describe it to keep it in simple terms. All buildings built since the mid-1970s are built with the ground snow loads in mind. Anything built prior to the mid-1970s definitely have a structural engineer take a look at prior to installing any type of snow retention. So if we started in an area with 100 pound per square foot ground snow load, what does that even look like? If we can assume that a person is standing underneath a building in one of these areas, 100 pound per square foot isn't a large snow load really. The Lake Tahoe area that we just looked at that picture, those can range anywhere from 300, 350 pounds per square foot. So there are definitely areas that go way over this, but we just did some math to kind of give you a scenario. If we take a 4-foot wide section of snow and decide that that's how much is actually going to hit this person, the roof is pretty short, so from eave to ridge, it's only about 15 feet, and that snow comes off, we're looking at 6,000 pounds that hits that person. So I'm not sure about you guys, but I'm not trying to be hit by a hippopotamus that's coming off of my roof. So those things also weigh 6,000 pounds, just to put that into perspective of how much weight we're looking at. Since the ground snow loads are worst case scenario, let's just split it in half and see where we're at. So obviously, if you can do the math, half of that is going to be 3,000 pounds. That's the weight of an average car. So 50-pound snow load is what we look at usually in the valley here in Utah. It's not a large amount of snow by any means, but once you get into those mountain resort areas, you're looking at much higher snow loads. So 200 pounds in a square foot is a pretty average snow load for a mountain resort area. With that total in that same calculation, so a 4-foot wide section, 15-foot long, you're looking at 6 tons, which is the same weight as an African bush elephant. And once again, not something we want coming off of our roof. So let's take a look now at learning objective number 3 and just recognize some of the damages that are caused by snow and ice moving on a roof. So since we're talking about tile specifically, these are just some examples that we've seen in person of tile being broken up by snow and ice moving. So the picture on the far right is going to be the most drastic picture, but this is just very simple examples, and it's not that the product is inferior, it's really truly just that this happens on all different roof types, and it's something that we're here to try to help with. And snow that sheds from one part of the roof to another part can also create damage. This is something that we always want to consider even while including snow retention to make sure that you're covering that upper area with snow retention with the lower area as well, because this damage can still occur if that's not taken into consideration. So these roofs here are not tile, but this is something that I just wanted to include to kind of keep these things fresh to your mind, that a lot of people have this assumption that asphalt shingles are going to be the snow stopper, and it just does not happen. So this deck railing has been removed multiple times from this home. There's another dormer broken on the home above that, and just a large amount of snow that has to be cleaned up. Penetrations definitely become victims to snow and ice that does begin to move. These specific ones, I'm not quite certain that they were applied correctly, but either way, it is something that does happen, whether it's the PVC pipe that we oftentimes see actually just sheared right off by the snow and ice moving, or also the metal type of conduit that's used for electrical penetrations, that we will see give way to heavy snow and ice, which is why a lot of times you'll see crickets, things like that being utilized. That can stop the harm from the penetrations, but it doesn't stop any additional damage that can occur as well. Other damaged property isn't just limited to your roof or people below any of those items. These are different types of examples. So the one on the left is something that's considered creep and curl. So you have your ridge of the home that's going to have the most heat escaping from it. And as that snow starts to melt up there, it's going to start moving down the slope of that roof out towards the eave. Once you get out towards the eave, it's going to be a colder temperature just because the air is flowing underneath it. Once that happens, it's refreezing, getting colder again, but gravity is already into play, and so it's starting to pull down as that happens. This often results in broken windows, and for mountain cabins that aren't utilized through the winter, it's one of those things that you come in the spring and just are not quite sure why your window is broken. Something also to consider there, that is a ski in, ski out area. So if that snow does decide to give way, you're on a pair of skis, maybe with your friends or family, your only other option to get out of there is that metal or that concrete retaining wall right there. It's just not a good escape route or a good place to be when the snow decides to let loose. The picture on the right just shows an example of a snow shed area that's shedding onto a gas meter. So a good example of this, a sad example as well, is in Canada. There was a home in Sun Peak where the snow did shed off the roof and onto the gas meter. The homeowners were responsible enough to go take a look at it themselves and at least make sure that it was still intact. They couldn't see any physical damage, and so they went on about their day. 3 days later, that home actually did explode, and luckily there was no one inside to be able to be victims of that. But that is something just that's very, very important to consider. A lot of building codes do cover that now, but if you're on a property and doing some retrofit work, things like that, that's something to take a look at as well. Also, something to see here that could be a danger or a potential hazard is just the snow that's overhanging on this roof right over top of these steps. There's already tracks in the snow, so someone is walking up and down these stairs. So that's just something that you always want to think about for children, yourself, your neighbors, anybody that might be stopping by. And property damage doesn't just include the parts of the building itself. So these are vehicle examples. The vehicle on the left is in New York. So this guy was walking out of a 5-story building when the top of the building did let loose with the snow and ice. It came down on his vehicle, crushing it quite tremendously and causing quite a bit of damage. The one on the right is just a different type of example. So here we're looking at PVC pipe that was utilized as rooftop snow retention. This isn't a practice that we as a company or as a professional of these types of accessories would recommend in any way, shape, or form. So it did not work. Obviously, PVC pipe can be great for irrigation work, plumbing, and sometimes it even struggles then. So it's not something that we want to utilize to hold back thousands of pounds of snow. And these were construction workers' vehicles outside of a hotel. And instead of just getting off work and being able to drive home, they now have to shovel out a large amount of snow from their vehicles. Learning objective number 4 is to compare and contrast some DIY solutions. So the first one that we'll go over is going to go over that same concept of the creep and curl with those broken windows and how can we stop this. Well, a homeowner kind of had their own type of idea on how they would fix this problem. Every season they were having broken windows due to the creep and curl type of situation. And so their solution was to put up barn style windows coverings that just slide right across the windows. So that's going to be the far left picture that you're seeing there. They know that they have an issue not only with the broken windows, but they also have large penetration or large crickets covering each penetration on their roof. So their other attempt was to just cover these. With that, they still resulted in broken window coverings and still broken windows as well. So this just did not quite work out the way that they had hoped. Snow retention in that type of situation definitely would take care of that problem for you. You wouldn't have to have the darkness in your home as well inside a beautiful cabin. The danger falling ice and snow from roof signs is something that we see very commonly. And oftentimes they are put in very strange places. As you can see in the picture on the right, we're going to put a handicap sign up and make sure that our handicap customers are well taken care of. But right above that, we're just going to let them know as well that, oh, just watch out because the snow does come off this roof occasionally, and I hope you can run very quickly. These also do not usually remove much liability from the owners or anyone who did put those signs up, just because it's basically saying, I know I have a problem, but I'm really choosing to do nothing about it. This is a quick video that just kind of started playing on its own. I don't think I'm going to run the video. I'm not sure that it's going to show very well for any of you. This guy is 3 stories up and just does not quite stay up there. He's not tied off. According to OSHA, every single year there are deaths related to rooftop snow removal. The people on the far right are on a brand new copper roof with metal shovels, cleats in their boots, and pickaxes. So that is not something that any building professional or any person that paid for that copper roof is really going to want to see. And then the damage from that is just something that you're not going to see this year, and it probably won't happen until spring, and you won't even know that it was related to your rooftop snow removal. This is also very costly to have done, so it's not something that's recommended unless it's absolutely necessary. The guy in the middle, I'm not quite sure what his end game is there, but it does not seem like it's going to be a good situation. So ground snow removal, once that snow does come off the roof, is very costly and time consuming. As mentioned at the beginning, I do have a background in ground snow removal, and you're looking at over $200 an hour for some smaller equipment. A truck is over $100 an hour, and anything above that is just going to be much more costly. That's not including any kinds of materials. So just some things to consider there, that it's not always just the dangers involved, but also what makes more sense here. So learning objective number 5 will present the similarities and differences between snow brackets and fences. We know that snow retention is not a new idea. So we've seen different examples of previous snow retention that happened centuries ago on outbuildings of castles and all different types of things. And that's what the example is in the far left picture. So they used boulders or large pieces of logs and situated them on the roof to help hold the snow in place. So the picture in the middle is about 8 feet of snow on, this is actually one of TRA's systems. It's a C22Z bar system, the fences, and that is holding all of that back on just 4 rows of a 2-bar system. So that's just a cool example to see how sturdy this piece of material is and what it's capable of. The picture on the far right is just allowing you to see the space that's underneath the snowpack, that's allowing for complete and even snow melt off and just letting that drain out of there properly. Snow does have an R value, so it's staying up there. It's being energy efficient, helping with some insulation. And moving forward, we will take a look specifically at the snow brackets. So there are no codes or standards currently that relate to anything to do with snow retention. With that, manufacturers can produce their systems or devices out of whatever material they would like, and that's just how it is. So if we wanted to take some pop cans and super glue them down to your roof and call it snow retention, you absolutely could. It's not something we do and not something we recommend. There are also plastic brackets out there, and once again, plastic is great for your Christmas light holders, and that's really about it for the rooftop. At TRA, we do try to always make sure that we're coordinating with the closest similar metals if applicable. That way we're making sure to take care of the roof product as well. This is just an example of a data sheet of our Apex A bracket. So we do these for every single one of our brackets or fences. We provide specifications, anything like that that's necessary as well. And I can also share these slides if there's anyone that wants to look at some of this information a little closer as well. So the most important thing to remember about the brackets is they're designed to stop the snow from starting to move, but not to stop moving snow. So a lot of times building professionals or even architects, anything like that, will just decide to put a row of these brackets along the eave in a very heavy snow area. Well, that will stop or split up the snow on the way down, except that snow is already glaciated, frozen together, and these metal brackets, although they are very strong, there's going to be an ultimate fail point to that system. And the bracket itself is not going to be the fail point in most cases. So either your fasteners or your roofing material, anything like that usually will be the thing that fails prior to that. Brackets are made to penetrate 3 inches into the blanket of snow and then have the snow freeze to it in one large mass. So that's why oftentimes they are placed across the entirety of the roof from ridge to eave in a staggered pattern. So it just truly depends on all of the factors that go into it on how many brackets are necessary, and they mount directly to the sheathing, battens, or the roofing product, where snow fences are a little bit different. They are actually designed to stop the avalanching snow. Once it's stopped, you still want the snow to freeze into place onto the fence. And the fences, so if it was tile specifically, they're going to mount directly into structure. So trusses, rafters, purlins, standing seam roofs, they clamp onto the seam. Learning objective number 6 is going to be to prove the importance of testing and engineering of snow retention systems. As I mentioned, no matter the strength of the retention device, if you're not considering every detail of the project, the snow retention can fail. So this is an example of that. Someone decided to DIY their own type of snow brackets. These were made with 1/4-inch plate steel. Once the snow began to move, it was not the brackets that were the fail point. It was actually the sheathing and everything else that was pulled out along with the brackets. So these should have been spaced out a lot more on this roof and throughout the entirety of the roof, not just along the eave. Other types of failures often can be due to the product that's being put up. PVC pipe, I have many pictures of PVC pipe coming down of roofs, or the picture on the right just shows an example of a deck mount type structure that or should have went into structure, and instead it's going into the roofing material with a bolt size that might hold up a picture or a shelf on your wall inside your home. So just not utilizing the proper fasteners and not putting it where it should be as well. So the factors that need to be considered while engineering a snow retention system are going to be the ground snow load, slope of the roof, roofing material, length of the tile exposure, type of sheathing and thickness, and then the rafter and truss spacing. So the manufacturer does need to know some of this information. The strength of the specific snow retention device, the pull-out strength of the fasteners, and where does the system ultimately fail is going to be information that the manufacturer themselves needs to know. So whether you buy it from us or someone else, these should be questions that should be able to be answered or engineered to. TRA ourselves, we are part of the ASTM task group working to create some standards for the snow retention industry. Any snow retention manufacturer should be able to test their systems to determine all of those factors. This graph is just going to show that no matter what the project is, even if it looks exactly like the project you had previously, or if it is the exact same project, and the only difference is going to be the sheathing. So the picture on the right is shows the number of brackets to install per roofing square into a 7/16 wafer board. So you're looking at 23 brackets, but only 11 for 3/4 inch CDX plywood. So the strength of that sheathing is going to be a huge factor. So if instead you decide to change up your sheathing, but you don't send in a new type of layout to be quoted for and engineered to that job, then you're ordering 11 brackets when you should be ordering 23. Or you're ordering 23 and charging double when you only truly need 11 for that project. So this is why we just take the guessing out of that for you and just handle the engineering on our side. So it's not a concern or an issue for you to either be under delivering or over quoting, anything like that. It's not your problem. So the importance of engineering does always include trying to avoid that partial installation. So once you have all of that snow retention up there and then you just leave out a chunk of the snow retention, the picture on the left is going to be that exact scenario. So this house backs up to a mountain. It's not necessary to cover the back of the home in snow retention, so they thought. So they went ahead and just put up enough to cover the gutters. Well, with that entire area of snow, that entire mass of snow across that roof is being held by one snow fence on 4 seams specifically. So those seams were tore out and that snow fence did major damage. Gravity is still trying to pull that stuff down. So that is something that definitely needs to be considered. And we always do try to avoid partial installation if at all possible. We understand you want to cover the walkways and doorways and those things, but the risk that's involved by only having part of the installation is just not engineering to the amount of weight and all of the factors that go into it. So this is an example of a free engineered layout for any project that you do have. We keep it very professional. All of the drawing information is there. The spacing information is there for you. It comes with quotes and any other possible information you could possibly need. We're always willing to help. And then we'll touch base very quickly on helpful design practices for the snowy regions. So the best solution that we've ran into as far as helping with the ice damming is going to be utilizing a cold roof system. So I have more information and some other abilities to get information on this. If you have any questions, feel free to reach out to me. It's not our expertise as far as TRA Snow and Sun, but it's something that we can definitely help with if needed. So we have 2 examples here of pictures. The one on the left is a traditional roof and the one on the right is a cold roof system. So with this, you're equalizing the temperature of the roof surface to the outside ambient temperature. It extends the life of the underlayment and helps to prevent ice dams. Your designs do have to be rather simple and your head walls must be vented. Just putting in a gable vent to try to help with this usually acts as an intake and actually does pull snow or debris into the attic instead of assisting. And then counterbattens are also something that can be a helpful design as well. They can extend the life of the underlayment, minimize the collection of dirt that blows in. Otherwise, once that dirt's in there, it just stays in there, sits, gathers moisture, creates moss, mold, and rots into the underlayment and the battens as well. So in closing, after touching base on all of those things, snow retention we really think is just the best solution to maintaining the longevity of a tile roof in snowy conditions. We do offer solutions for all roofing types and provide free engineered layouts at any time, even if it's just a custom situation or your own home, anything like that. We're happy to help. Layouts can be sent to sales@TRA Snow and Sun. I know my information will be up as well. Feel free to send them to me. I am on the road quite often, but I'm more than happy to make sure that they're taken care of either way. And now we will just open it up to any questions or concerns.
Mindy, thank you, first of all, for a fun and funny presentation too. And it reminded me, there's one manual we have I didn't mention, and that is the Snow and Cold Manual, which was co-authored by Terry Anderson, who was the founder of TRA Snow and Sun. I just want to share my first experience being from Western Washington. We don't have that kind of severe heavy snow, but about 10 years ago, I was asked to go do an inspection in Whitefish, Montana. So as you describe some of these problems and challenges in a funny way, These homeowners had built their dream house in Whitefish and gone to Palm Springs for the winter with no thought to the design. They had a low profile black concrete tile direct to the deck, no battens, in Whitefish, very large home, high altitude. And when they came home, they actually called the police thinking that there had been vandalism to the house. The gable tile were ripped off in areas, and almost around the entire perimeter, the first row and a half had looked like somebody had put a ladder up and hit it with a hammer and ripped it off the roof. You know, I was called by an attorney just to help try to find out what happened. So I went, and with this TRIA snow and cold manual, to be able to go through that manual and see how well it explained what not to do, and they had done pretty much everything. I had to tell them, I have no way to tell you what you should do. And that's where the technical support and the engineering support really comes in. My experience was a real learning experience. And if I were to ever do anything again, just like we've done with you on our personal house, we would reach out and look for that support initially.
Absolutely.
Today, there are tremendous accessory and component parts and pieces and professional support, like you see from TRA Snow and Sun, and you know, utilizing those components and the professional support really can help mitigate the challenges we have with labor shortage and efficiency up on the roof. So, you know, we encourage that, and anything you can do to help our industry with knowledge, Mindy, we're very appreciative of.
Absolutely.
Mindy, we very much appreciate you being so well prepared with a great presentation, and thanks to everybody that came on today. And I'll give the last closeout to you, Mindy.
That is all I have. So I appreciate the TRI and everybody working with me. Lisa and John, you guys have been wonderful, so I appreciate that. If you need anything from me, don't hesitate to reach out. Otherwise, I look forward to moving forward.
Great. Have a great weekend, everybody.
Thanks, you too.